what actually the Thomson's atomic model is. It's the first model regarding structure of atom proposed in the year 1897, right? And according to J.J. Thomson, he felt like there should be positive charge within the atom because he is the discoverer of electron. He knew that electron carry negative charge, and as well as he knew that atom should be of neutral. Atom charge should be a neutral charge. So basically, electrostatically, no atom carries any charge. I mean, atom is basically neutral in charge. So as to balance the negativity offered by electrons, he said that there will be positive charge within the atom. And how do that negative charge, I mean electrons and positive charge within the atom got distributed means, according to his view, it is like as I written here, according to this model, you can read here, the positive charge of atom is uniformly distributed throughout the volume of atom, and negatively charged electrons are embedded in it like seeds in a watermelon, and hence this was said to be as plum pudding model. So as he wants to explain something about the structure of atom, what he said is that if this is the atom, the complete volume of the atom got fitted by positive charge, completely volume got spread through positive charge, and here and there like seeds in the watermelon, electrons will be fitted. This was his imagination. Of course, he said what? Atom is still electrically neutral because positivity got balanced by negativity. And as it is like plums in the pudding, even we can call it as a plum pudding model. Okay? Basically, because of its own drawbacks, it has its own failure things. It has its own limitations, so that we have next atomic models in the history, right? In the development of atomic models. So let us see here what is actually the limitation, or what are the actual limitations of the Thomson's model means. This model could not explain all the features of spectrum of hydrogen and of other atoms. Here we need to take care one thing about what actually this spectrum of hydrogen or spectrum of other atoms is, because even this is going to be continued limitation for Rutherford model, right? Niels Bohr said some atomic model, somehow he explained the hydrogen spectrum, but even he failed to explain the spectrum of other atoms. So there is a necessity of having the discussion of what actually that spectrum is. So we know that electromagnetic waves, because it was said in 1897, by the time of 1897, around close to the end of 19th century, there was a firm established wave theory of light saying what? Light is nothing but electromagnetic wave. So all the people knew that these are radiations or electromagnetic radiations are having their respective wavelength, their respective frequency, their respective energy. And these electromagnetic waves in their order, if you write like starting from gamma to like last one radio, including here X-rays, UV, visible, infrared, micro. This is what we call as a spectrum. Wherever you read the word spectrum means what? Grouping of different frequencies or grouping of different wavelength. Proper arrangement of different wavelengths is what we call as spectrum. This completely from here to here, this is what we call as complete electromagnetic spectrum. Only if you concentrate the visible part extending from violet to red, that is what we call as a visible spectrum. What actually here happened, in that period of time, people used to conduct the experiments on different atomic gases. I mean, different gases will be taken in the evacuated tube, like our discharge tube. They used to send some external energy to them and they need to excite them. Okay, and usually those atomic state of gases, after getting excited, in the process of de-excitation, they used to give some radiations as the output. If you send those radiations emitted by the atoms in their de-excitation, and if those radiations got collected on the photographic plate, This is a photographic plate, and you can know after development of the photographic plate, you can see some lines over that photographic plate. This is what we call as a spectral lines. I mean, as a radiation shown some impact on the photographic plate, it has been some achieved as a or collected as one line, so that each and every line represents what the in that space of the photographic plate, in this space some radiation got interacted over this space, so that we got some line. So these lines are nothing but representation of the interacted electromagnetic waves. So group of electromagnetic waves we call as a spectrum, no, so that these are we call as a spectral lines. So whenever you read the word spectral lines, it means you need to go for imagination as if there will be some sort of lines formed on the photographic film which represent spectral lines. They are there on the photographic film because some radiations would have interacted with the photographic film. Henceforth, you can see some spectral lines, some vertical lines on the photographic film. Those vertical lines are nothing but spectral lines. So, if in this chamber of evacuated region, if you put one element like a hydrogen, and if you exert the hydrogen, obviously with some external energy, see, no object will be in the exerted state for longer time. Obviously, they have to come to the ground state. So, while coming to the ground state, that is what we call as a de-excitation. They used to emit the outcome radiations. Electromagnetic waves will be emitted out by those elements. That is what we call as collected radiations fallen onto the photographic plate. Formed lines we call as spectral lines. Is it clear now? Spectral lines means this is what the explanation, a brief explanation you keep in your mind. So every element will have the capacity to give its own spectral lines when they got de-excited after getting excited. So when they propose some atomic models, because this is after all the material which got excited and which got de-excited is nothing but the matter, nothing but which consists of atoms. So all the people, all the community of scientists used to ask a written question that explain the spectral lines formation with your model. This was like a frequent question which comes to the in front of the proposed scientist. I mean, whoever the scientist proposed one model, immediately he has to answer the spectral lines of those different atoms, whichever the considered sample which have been taken in the given evacuated chamber. So if you take here hydrogen, this is what we call as hydrogen spectrum. If you take so and so sodium, it is called as sodium spectrum. If you take this as zinc, it is what we call as zinc spectrum. So they are responsible to explain the available spectral lines on the photographic film with their respective atomic models. So even J.J. Thomson with his basic first model of atom failed to explain how do these spectral lines got formed. Got my point here? And you know why we highlight here spectrum of hydrogen every time? Because instead of taking other atoms having many number of electrons, got my point here? We preferably go for very simple thing, that is hydrogen atom having one single electron. Instead of attempting a first difficult complex work, first they have asked, please explain the spectrum of hydrogen. Thereafter they can go for explaining the spectrum of other atoms. So for the simplest thing itself they got failed. That is the case here. To explain the simplest spectral structure of hydrogen atom, they failed and forget about other atoms. That is what the main fail of, drawback or limitation of J.J. Thomson. Even this can be the continued limitation for Rutherford model. And you know, the second one, the limitation in the Thomson's atomic model is, as I have written here, it also failed to account for the large angle scattering of alpha particles as they pass through atoms. I mean, this you can understand in a better way after learning alpha ray scattering experiment done by Rutherford, because there you can come to know what happened if you send the alpha particles through the gold foil. So even that explanation also unable to give satisfactory explanation over that observation by Thomson's atomic model. Hence, I can fit these two as important limitations of Thomson's atomic model. This is what actually about brief information about the J.J. Thomson's first atomic model, and it is very important thing to notice here that at the time of proposal made by the Thomson's about his first atomic model, at that time there was no discovery made about the proton and neutron. Remember, they even not know about the existence of proton and neutron. Simply they said that some positive charge will be there surrounding the complete volume, fitting the complete volume, and here and there electrons will be fitted, that's it. Okay.